Welcome to the Calculus A section. This is a very brief section that does not entail an application of derivatives, but an application of tangent lines. The linear approximation is essentially the approximate derivative at a given point. So given the function f of x, we can find its tangent at x equals a. So let's say the linear approximation denoted by L of x is equal to f of a plus f prime of a times x minus a. And this is our linear approximation formula. This is important. So because we know how to compute everything in this formula, we can just jump right into a problem. So let's say that we wanted to find the linear approximation of the function, let's say 3x e 2x minus 10, and let's say at x equals 5. Now this is a very daunting derivative, but trust me, it's not too bad. So when we take the derivative of this equation, we are going to use the product rule, and we are going to use the exponent rule, my apologies. So we can say f of x is equal to 3 of x prime e 2x minus 10 plus 3 of x e to the 2x minus 10 prime times 3 of x. And so we know this is going to be 3 times e to the 2x minus 10 plus 2 times e 2x minus 10 times 3x. Okay, so now we're going to plug in f prime of x. This is f prime of x, and we want to plug in 5. F prime of 5 is equal to 3e times 10 minus 10 plus 2e 10 minus 10 times 15. And so we know that e to the 0 is actually equal to 1, or anything to the 0th power is equal to 1, so we can say that 3 plus 2 times 15 is equal to 33. Now when we're dealing with f of 5, we can just plug this in, and it is going to be 3 times 5 times e to the 0th, and that's going to equal 15. And now we can see our formula is f of a, which would be f of 5 in our case, plus f prime of a, which is f prime of 5 in our case, times x minus 5. So the linear approximation formula is going to look something like this. We can actually switch colors to make it stand out a little. So L of x is equal to f of a, which is f of 5, 15, minus f prime of a, which is f prime of 5, 33, times x minus 5. And that is our linear approximation, and that's all that there is to it. If you need any more help, there are a bunch of problems on the website, and I hope that helps. Thanks.